In this lesson, we shall focus on mathematics 1B, Math 141, tutorial 11, conic sections, sketch the hyperbola, identify the vertices, foci and asymptotes. Right, so in A, you have y squared over 9 minus x squared over 25 equals 1. And we want to determine the vertices, and we want to also determine the foci, and also the asymptotes. But most importantly, we need to sketch the hyperbola and identify those features. So now let us actually quickly look at the following. But first, we note that to sketch this particular graph, we need to first find its center. So we have a center. This has a center as 0, 0. And now if there's a center 0, 0, we note that our a squared is always the positive, which is 9. Our b squared is the 25, so that we see that a is 3 and we see that b is 5. Right, if a is 3, it's going to help us to get the vertices, because a, now since, this is what we say, since a is 3 and 0, 0 is the center, okay, I'm starting with this because it's relatable. We ended here yesterday. Right, then the center is transformed. Right, is transformed. How is the center transformed? It is transformed because y is where the a is coming from, so you're going to affect the y component. So which means you're going to add 3 and subtract 3 from the y component, getting 0 plus or minus 3 there. Now, after we got, and this here would give us the vertices. Simultaneously, we need to find the foci. C becomes the summation of a squared together with b squared, always for the rectangular hyperbola. The a squared is a 9. The b squared is 25. The sum is 34. Okay, now, after we got the C, then we actually able to find the foci. The foci are obtained from the center, which is 0, 0. And this center is transformed accordingly, in which case we add and subtract from the y component because it's y with the a. Okay. Which is plus or minus the square root of 34. Simultaneously, what we then say is therefore that y is equal to, for the, okay, we make y the subject out of this. You make y the subject, you cross multiply, so it's going to always be plus or minus the square root of the 9, the square root of 25. Yeah, it's y equals plus or minus a over bx. You can write that without making things complicated. So it's going to be 3 over 5 x. And then we have found the asymptotes. And then we can sketch everything right now. Okay, simultaneously realize we have y together with x. So right now, the vertices, it's going to be a 3 minus 3 as well. So their graph is going to be exactly this way. And then now at this pointer, the vertex is 0, 3, 0, minus 3. The foci, we actually obviously obtain it from C, and it's going to be the square root of 34. It's just about close to the square root of 36. So it's like 6 point something, thereabout, just 5 point something, excuse. So you have the square root of 34 minus the square root of 34. Okay. Yeah, that's a good question. Is the asymptote always A over B? We will reason. It's actually whenever y comes first, it will be that way because it's y minus k squared over a squared minus x minus h out of b squared. We make it 0. And then we make y the subject of this. That's the reason. So we're going to do it in 2 ways because either x is a subject or y is a subject of this. And just that. So you'd have y minus k squared, which is a squared over b squared. Take the square roots. So you have this one. So then in the end, yeah, so if then it becomes a over b for the general translated rectangular hyperbola. What about if we have x minus h? Because there are 2 formulas we learn. Right, such that the focal axis here becomes parallel to the y-axis because y is positive. So here we then say the focal axis, right, is parallel to the y-axis. You have y minus k squared over b squared equals 0. Okay, these are the 2 formulas we'll ever encounter in this course. So, yeah, and then we have other translated shapes. Okay, right, let us make x a subject out of this. Which means here we're going to have x minus h squared. Which is y minus k squared. Right, so we would get the following. Right, so we'd have that this is equal to the square root of a squared b squared y minus k squared. And this in the end becomes what? Becomes exactly x minus h a over b y minus that. Okay. So If x is positive, it will be a over by. Right, so, but as you can see, it is actually very, very important to note that it really depends, therefore, on what the subject of the equation is going to be. So these would be the asymptotes. Of course, you have plus or minus here. Or you can say y minus k becomes b over a, x minus h. So it means it can be either a over b when y is positive. When x is positive, it becomes b over a. So you can note it that way. Right, so, but it can be a over b all the time, but if x is positive, then you know it's x minus h, then it's a over b. Okay. Right, so you're going to have at this point, you're going to have the 0 plus the square root of 34. And then you have the 0 minus the square root of 34. And this is the answer. And that becomes the answer. Where the origin is that one. All right. Where the origin is that one. Right, where the origin is that one. Where the origin becomes exactly that. So we continue. So we continue. Let's move on to the next question. Right. We're moving on to 1B. Sketch the hyperbola, identify the rates of those features. You can see that always y is the subject. So it is either a over b or b over a. Okay, because you can see that here x is first. So as we've indicated that in our investigation, if x is first, then it becomes b over a. If y is first, it becomes a over b, of course with plus or minus. Right. Let's investigate that. Okay, now we have this. Right, so we have exactly this. We have exactly this. We have exactly this. Okay, now let's look at this. Or to look at this one now, you need to sketch it. 6x squared minus 25 y squared, you divide by 400. But first, you can just equate to 400. Then you divide by 400. Right, so We can simplify this. Divide by which is out of 25. 16 out of 400 is 25. So this is going to become x squared out of 25 minus. So if you do 25 divided by 400, so y squared out of 16. So that our a is always on the positive things. So a squared is 25. The b squared is 16. I mean, we're following the textbook's approach to this. Meaning a is 5, we take the square root, b is 4. As usual, we do the following. We do the following. We say since. Since a is 5, the vertices, we take it from a because it's a positive term, but because x is first, then it's going to affect the first component. Okay, because the center is 0, 0. And then the vertices are going to be 0 plus or minus 5. It affects x, giving us plus or minus 5 and 0. The foci are okay. The foci are, you take the center and it's going to affect only the x. Center is 0, 0 for this. But now, yeah. But first, before we do the foci, let's get C. We need to find C, the sum of the squares. So our C becomes the square root of a squared plus b squared. A squared is 25, the b squared is 16. Then what is the sum of this? It's exactly 41. So you can say that's the foci are. Zero plus or minus square root of 41. So yeah, I'm just putting 0 because the center, you add to the 0. Leave the y unchanged. Plus or minus the square root of 41 with the 0. And these are the foci. These are the foci. Let's talk about the asymptotes. Right, to get the asymptotes, you can just say To get the asymptotes, it's so easy. I mean, you can always memorize it's A over B, where A is on the positive. So you can always say the asymptote is going to be Y because A is on the positive. So it is plus or minus this one, the A, which is 5. So, but obviously because the X is first, then it becomes the other way around. This is what I was saying. So it becomes B over A. So it becomes 4 out of 5x. So, but how do you know if it's B? This one is like y is plus or minus B over A. So now we return to this. It was saying x is first. So we can write, okay, I want to talk about the asymptotes. H squared over A squared. K squared over B squared is 0. Always make it 0. Okay, with a minus. Right, so it means therefore we're going to have x minus h, which is a squared over b squared, y minus k squared, getting x minus h, taking the square root is a over b, y minus h. Us answering the question whether it's always a over b, b over a. So we make y the subject. You can see, always make y the subject. It would have been a over b all the time. Make a, when x is a subject, you make x the subject. But yeah, it's not like that. You can see the answer. This is going to be plus or minus there. So the y, therefore, is plus or minus b over a y minus k. So that's just what we have. So y minus k, therefore, is plus or minus b over a. X minus k here. X minus h. X minus h. So now we can sketch the graph. Sketch the graph because x is first. It's going to be on the x-axis. But now you need to plot the vertices. You will have minus 5, then 5. And so now you need these are the vertices. Then you need the foci minus square root of 41. Okay, for square root of 41 is close to the square root of 36. Minus 6 point something. So you're going to have minus the square root of 41. And then the square root of 41. Through the origin, it's going to be the asymptotes. One with a positive slope like this. The other one with a negative slope like this. So y equals 4 out of 5x. Y equals minus 4 out of 5x for this. Okay, and obviously it is standard practice to sketch these and make them solid. It is standard practice to make these solid. So take note of that. Right, take note of that. Okay. Right. But now you can make them dashed. Because the textbook makes them dashed. So you can make these, the asymptotes dashed. The asymptotes dashed.
I think this
So we continue.
statement confirms that there's a total disjuncture between government.
Right. Okay. Right, right, right. So we continue. So we continue. Right. Think about it and make sure you understand. So we continue. Make sure you understand what is happening. Look at the next question. Sketch a parabola in that, so let's practice with this one. First, we must find the center. First, we must find the center. Right, we must first find the center. Right. Right. We continue. We continue. So this would be -1 and 3. And this is the center. Okay, so we continue. We continue. Right, so what do we do? We find the A and the B, etc. The center is there. We have x plus 1, we square it. Y minus 3, we square it, divide by 16. This is x plus 1 squared. This is exactly a 2, and it is equal to 1. So the center is -1, 3. Right. So now, A is always, because there's nothing here, you can write it as 1 squared. So A is 1 squared. So it means, therefore, B and our B becomes what? Becomes the square root of 2. Take the square root of this because this is B squared. Now, we found the A and the B. We can find C as well, which is A squared plus B squared. But not the other one where it says A is to what is bigger than B in the case of the ellipse. Yeah, it's different here. This is not like the ellipse. So the A squared is 1. The B squared is 2, and this becomes the square root of 3. So we continue. Okay. Since A is 1, okay, because we focus on the A, because it gives us, it tells us exactly by how much you need to adjust along the focal axis. So because now X is positive here, and Y is associated with a negative, Y is associated with a negative. So since A is the case, you transform the center The center is this, but we're going to only transform the A is going to change the X component. So, which means then the X component is going to be what? Right, so this is the center minus 1, that, and then you add 1. So minus 1, you add 1, subtract 1. But now it's easy. Minus, you add 1 and also you subtract. And also you subtract. And also you subtract. So we continue. We continue. Right, so we continue. Zero 3 minus 2 3. Okay, so these are the vertices. So here you can just write out the foci. The foci will be located where? The foci will be located where you have the center, and then to the x, because it's positive and A is related with x, you add and subtract the C to the x. So it means that the x is x component is minus 1, but now you add, subtract the square root of 3 to the center. Okay, so this gives us the foci. What about the asymptotes? Right, so the asymptotes, right, so we just write x plus 1 squared minus y minus 3 squared is 0. And then you make x, you solve. Solve for x. So which means that you can see that x plus 1 is going to be plus or minus 1 over the square root of 2y minus 3. But as we said already, we always make y the subject. In this case, for the asymptotes, they can see it's y minus 3, but they make y the subject. So which means that you're going to have y minus 3, then it's going to be plus or minus the square root of 2 x plus 1. Square root of 2 x plus 1. So then in the end, right, so then in the end, you then have this as the asymptotes. Then obviously you can see that it's always y the sub, but if x is first, then it is b over a. Plus or minus, it's b over a. Okay, let us draw the graph here. Let us sketch the rectangular hyperbola. Let us sketch the rectangular hyperbola. Let us sketch a rectangular hyperbola. So now, in order to actually note the vertices, and so now, where is this point? Where y is 3. Here, it's very interesting. And then there's another point where y is 3, is this one. Here, x is minus 2 and y is 3. Right, so because x is positive, the focal axis is going to be parallel to the x-axis. Okay. So the graph is going to be cutting like this, through the vertices, always, through the vertices, through the vertices. But now, then you're going to have the foci. You're going to have the foci. Okay, you're going to have the foci. Right, so the foci then is going to become this one. So the square root of 3 is like 1 point something, but minus 1 is then going to be 0 point something. But it's going to be 0 point something. Minus 1 plus the square root of 3 is going to be 0 point something. So it's going to be minus 1 plus the square root of 3. And the other one is going to be minus minus. So it's going to be like minus 1 minus, because this is like minus 2. But minus 1 minus 1 point something is minus 2 point something, which is minus 1 minus the square root of 3 together with 3. Okay, that gives us the right. That gives us the foci. Then we need to just catch the asymptotes. Well, these asymptotes would pass through the, what are the coordinates of the center? They pass through the center. So through x equals to minus 1 and y equals 3. So one of them is going to be like this, but we make them dashed, and the other one is going to be this way. Right. It's going to be that way. So that then in the end, what you're going to have is therefore that y minus 3, 1 is the negative slope. So y minus 3 would be this one, negative slope. Right, so y minus 3, then the other one is a positive slope. Okay, and they pass through the center with minus 1, 3 coordinates. And this is the graph. Any question about this? Any question about this? So we continue. We continue. Right. We continue. Right. So we continue. Right. We continue. Right. So we continue. Any question about this? Right. Any question about this? Think about it and make sure you understand this. Right. Think about this and make sure you understand it. So if x is positive, like it is here, associated with a positive, then it is a b over a. The asymptotes have b over a. Right, so the asymptotes will attain b over a. In other words, what we're saying is for the asymptotes, which is b over a. B over A. Right, think about this and make sure that you understand what's happening. So we continue. Let's try the next question. Let us try the next question. Okay, we're doing C now. Right, so now let us look at conic sections, but looking at number 2. Find an equation for the parabola that satisfies the given conditions. So we're looking at 2A. We have the foci. Right, we have the foci. We have the foci. with the foci. Right. Okay. 2a. Find an equation for the hyperbola that satisfies the given conditions if the foci have been given and the asymptotes have been given. So we're looking at 2a. The foci had given it plus or minus that. And the asymptotes also have been given. So the asymptotes obviously either have A over B or B over A. So which is which? Right, so the foci is there, but you can see that the center, because now this must be y minus k plus or minus, right, plus or minus either a over b, then x minus h. But because these foci, their numbers sitting where? They're numbers which are sitting on the x. They're sitting on the x because you have a -4 and a 4. It means, therefore, that the graph is somehow like this. So if the graph, it means, therefore, the focal axis, right? So it means the focal axis is parallel. It's parallel to the x-axis. Right. Y over x. Okay, so it means that the center, what I was saying is that for the center is 0, 0. And then a graph like this, it means that for x is positive. If x is positive, then you're going to have x coming first. Squared over a squared. This is the formula that we're going to use. Y minus k squared over b squared equals 1. Okay. Now, if this is the case, the asymptotes, but also the foci in the asymptotes, everything will be given by what? So you solve and you make X the subject. Okay, obviously you can always memorize this already. But for the asymptotes, you have X minus H A squared over B squared Y minus H squared. Which is A over B Y minus K. And then if X is coming first, then it is Y minus K, which is plus or minus B over A. Right, and by dint of this, it would mean a couple of things, but it means that C is the square root of A squared plus B squared. And then your C is 4 plus, you added plus or minus 4. It means you're going to have 4 equals A squared plus B squared. Like that, and that. This sort of gives us an equation. Right. So you'd have that 4 is the square root of A squared plus B squared. But also we have the plus or minus B over A, which is plus or minus 2, because it becomes B over A. Square both sides getting 16. B equals 2A. Put 2 into 1. These are simultaneous equations. These are simultaneous equations. Put 2 into 1. The B is 2A. Which is 5A squared. It's 16. A squared is 16 out of 5. You take the square root. Which means A is 4 over the square root of 5. Yeah, that's the question. How is B equals 2A? We just cross multiplied here. We just cross multiplied. In essence, you can just leave out the plus or minus. Because in essence, the A and the B are positive numbers, the way we studied them. So, but because we have been given the asymptotes, right? So if you're given y equals plus or minus 2x, and you already know that if this is the foci with 0, it means that the foci are sitting here. So the graph is like this. So which means that x is first. Which means that x is first. If x is, the x squared is first and the y squared is second, it means that the asymptotes are plus or minus b over a. But they've already given us. So it means that the b over a, because if x is first, then it's b over a. It means, therefore, that the b over a is actually equal to 2. It's actually equal to 2. It's actually equal to 2. Okay. If b over a is 2 because of this, because it's b over a, well, we can put plus or minus here, but it's not necessary. Because ultimately, as I was like, I put plus or minus, in the end, it means b equals that. So alternatively, for simplicity, we can just write b equals 2. Well, I mean, this is true because y is plus or minus b over a x, which means b over a is 2. Right. So we continue. We continue. So a is therefore 4 over the square root of 5. Yeah, we take positive a. And the b, all right, we've already got the b equals 2a. Because the a and the b are positive numbers, the way we started them. So now we have 2a, which is 8 out of the square root of 5. 2 by 8 is 16 over the square root of 5. So we got the a and the b. We got the a and the b. Now, if we got the a and the b, then you'd have the x minus h, y minus, yeah, minus in the middle, y minus k. Yeah, we're still doing the a part over b squared. Okay, in this case of the hyperbola, a is always associated with a positive term. But we've already seen that the center is the origin. So it's going to be 0. But what is the a? It's 4 out of the square root of 5. B is 16 over the square root of 5. So it's going to be 4 out of 5. And then you'd have okay, yeah, because the A just that's extra factor. The A is 4. So this is going to be 4, then getting 8. Eight over the square root of 5. So now the B is 8 out of the square root of 5, and then you square everything. If you square 4, 4 squared is 16 out of 5. 8 squared is 64 out of 5. Which is the answer they got. Which is exactly the answer they got there. Okay, so is the answer they got to A. Is the answer they got to A. Let's look at 2B. Look at 2B. Okay, in 2B, you have been given the vertices. And the foci are those. So let us, sometimes to sketch helps a little bit. Because if you're just given the information, it's not very clear what's happening. But what you want to see in the diagram is where does the focal axis lie? Is the focal axis parallel to the x-axis or is parallel to the y-axis, etc. If it's parallel to the x-axis, then your graph is like this or your graph is like that. So this is what you want to see. Okay, but if the vertices here are y is 4, so obviously we want to check this. So let me remove the assumptions of where the graphs should sit. But now this one is 0, 4. And then the other one, y is 4. And the other one, y is 4 and also x is 4. Just to create a bit more space here. So you have this. So there's this one that says y is 4. There's a point here that says 4, 4. The y-axis and the x. Right. Okay. So let us continue. We continue. Right. We continue. Okay. So the vertices are going to be there at 4. So there's going to be a vertex. The graph goes through the vertex. And the graphs go through the vertices. So the graph is going to be something like this. This means the focal axis is going to be parallel to the x-axis. So this is going to be our focal axis at 4, 4. But you see, the foci are 10 units apart. So, okay, we're just having a picture of these. We need to find a diagram. So this, because it's sitting like this, then it means that x must be coming first. So it's x minus h squared, then the y is coming second. But always In this case, the A is sitting actually below the positive. Okay, so now the question obviously, the vertices are these, and the foci are as described. We want the center. Right, so the vertices are there. So now we want the center, and the center is the midpoint of the vertices. So if this one is 0, 4, what is the midpoint? You have 0 plus 4 divided by 2, you have 2. And you have this one for the x, 0 plus 4 divided by 2, because the midpoint formula is x1 plus x2 out of 2, then we have y1 plus y2 out of 2. And this would characterize the midpoint formula from high school. This is the midpoint formula. 0 plus 4 divided by 2, you have 2. Then now you come to the next. For the x, you have got 2. What about the y? It is just 4. Okay, but you can say 4 plus 4 divided by 2, you get 4. Okay, but yeah, it's on the horizontal line there. Okay. This has given us the center. Right, just given us the center, which is 2, 4. And this gives us HK, meaning that our H is 2 and our K is 4. Okay, so we continue. We continue. We continue. Okay, y'all, we continue. Okay. So we continue. Okay, we found the center, we found the H and the K. But what do we want? We need to find the equation. So we're going to put the H and the K there, but now we need the B and the A. But how do we find the A and the B in our situation? So you need to think about it. So there's information given about the foci that are 10 units apart. 10 units apart. So the foci would be, for the foci that 10 units apart, it means therefore you're going to have from the center, you add the same distance, both directions. So if they are 10 units apart, it means that we have 5, 5. 5 units here, 5 units there. So if the center is at 2, 4, you add 5 units. So in particular, this gives us our C. It tells us that because we add C to the center, so you add C, and what do you add? If you have 5, 5, then it becomes 5 plus 2, which is 7. And then now 5 units backwards. 2 minus 5, you have minus 3, 4. Okay, so this is what we have. So you see what it means is therefore that our C is 5 that we added in both directions. that we added in both directions. At this point, we got our C. But the question still remains, what is our A? What is our B? Now, it's easy to get the A and the B, and there are too many ways, because now if you already got the center, you need to look at the distance. A is added, like 2 plus A is 7. Yeah, 2 plus A is 7. 2 minus A becomes -3. Okay, if 2 plus A is 7, it means that A is equal to what? A is 5, because you can say 7 minus 2 is 5. But also even here, you get that A is 5. So we got that A is 5 from distances. What about the B? Okay, to get the B, obviously, you need to use the formula, because now B, we don't use it much here in the transformations. So, but our C is A squared plus B squared. Right, we got already that our C is 5. Yeah, and our A is 5 squared. Yeah, in the formula, C equals the square root of A squared plus B squared, but we have that our C is 5. You square both sides, getting 25. Right, getting 25. And then is equal to 25 plus B squared. Okay. Yeah, that's the question. How is A 5? Okay, yeah, that's the error, because A has to be the distance from the center to the vertex. So it must be 2 plus A equals 4. 2 plus A equals 4. So that is going to change the A. So we have 2 plus A equals 4. 2 plus A equals 4 for the vertex. And therefore, which means that our A is 2. Even if you do it the other way and say 2 minus A, you have 0. A is 2, which is 2 squared. You square both sides, you have 25, and then it's 4 plus B squared. So that B squared is 21, and B is the square root of 21. So we got the A and the B and everything. So we got the A is 2. The B is the square root of 21. And the C is 5. So right. So that you come to the thing, and you found the center. What is the center? 2, 4. So x minus h squared over a squared over a squared, yeah, minus the y minus k squared over b squared is 1. The center you already have 2 for x. Okay, but now let's check very carefully here. Let's check very carefully. Uh-huh. Okay, I need to check these carefully. But you see, now we're going to put here for the axis 2. Yeah, but it's like it's the other way around. Need to check. Their a is going to be like 2 squared. Something I need to check here. The y, and then the b is the square root of 21. You square it, which means x minus 2. Okay. Yeah, that's the thing. You see, I'm finding that the answer is like, it's the opposite of what I expect. The variables are switched around. I need to think about what's happening here. So this should be that over the 2 squared is 4. I'm trying to compare and reason. Why would the answer be as they've given it? You see, I'm interested in that. Why is the answer like that? So if the vertices are this, how is the graph? Because y is 4. And then the other one, x is 4, y is 4. And they said these are the vertices. So if these are the vertices, the graph always sits on the vertices. And a graph that sits on the vertices, like this, tells that x is positive. Yeah, they did something wrong. Obviously, I would have to convince ourselves that this is the case. We have to convince ourselves that this is the case. Because if these and these are vertices, what happens in the graph if you substitute a vertex into the graph, into the equation? Substitute a vertex. Like you put 4, 4. What happens if you put a vertex into the graph? Because, well, the vertex is a point on the graph. Yeah? It's a point on the graph, so it must make the graph true. This is it. So if you're going to take any vertex, so you already see the okay, I'm trying to check here. A vertex is a point on the graph, like this one is a vertex, which is 0, 4. So if this then is the vertex, I'm going to take a vertex like 0, 4. Or we can take another vertex 4, 4. Okay, let's take 0, 4. X is 0. Y is 4. And then now this is minus 2 squared, which is 4 over 4. Because this one is 0, which is 1, which is equal to the right-hand side. So indeed, we expect 1. But also, if you substitute the 4, 4, it's going to be 4 for x, which is 4 minus 2 squared over 4. The y is going to be 4 minus 4. You square it over 21, and 4 minus 2 is 2 squared over 4. What is 2 squared? It's 4 over 4, which is 1 indeed. But let us check their answer. See, the claim is that these are vertices. Vertices are points on the graph. So substitute into the graph they got. So if they claim that the answer is true, which actually to me it looks like the opposite of what we got. So which is x minus 2 squared out of 21. And then when I substitute a vertex, which is a point on the graph, it must make the equation true. So if we substitute like 0, 4, when x is 0, you put 0. Right. And this is 21. And then you put, we're taking the point 0, 4. So the point 0, 4 into this is going to be y is 4. So the answer obviously does not even satisfy their own equation. Minus the x is 0. Okay, the 4 minus 4 is 0. But if you have now, this is out of 21, and then you have the 2. You have the 2 here because you're putting the 4. So it's 4, the x is 0 minus 2. So this is going to be 0 minus, you square the minus 2, you get a 4 divided by 21. You see, the 4 divided by 21 is not 1. It's not 1. So they switched the other things around. So the answer is wrong. Okay, if it were correct, then it was supposed to satisfy the 2 equations. I must thank you for joining us. It is just 10 minutes after 10. And because obviously we had planned to start at 8 and it's 10 minutes after 10, we're going to take a break. And I'm going to send you the recording so that you can watch. It's not a lot, of course, but you'll watch these things on the rectangular hyperbola. It's very, very informative. Right, so if you watch this, then you must be very, very perfect with the rectangular hyperbola at the end of the discussion, at the end of watching the video. Let us take a break, then I'm going to chat with you on WhatsApp. I'm going to send you the nearest time possible at which you can meet. Yeah, I get your point, but let's take a break. Because, the reason is we planned 2 hours. I hear you. We planned 2 hours. So now it's 11 past 10. Let's take a break. Okay, taking a break increases our efficiency so that we are more efficient. We don't make mistakes a lot. Because if you don't take breaks, then you're going to make a lot of mistakes. It is not right. Okay, so right. I understand, but just that we had planned from 8 until 10. We started a little bit late, of course, but still we have gone beyond the time because it's like 12 past 10. So on average, it's 2 hours. We started into the time because we started late. I waited, but it's okay. It's not train smash. You're right. Yeah, let's take a break and then I'm going to chat with you. I'm going to send you the nearest time. No, don't think that I'm punishing you because you're late. No. But taking breaks is good for the mind so that the mind can be fresh. We're gonna resume again. So I'm gonna send you the nearest time. Okay, yeah, let's take a break and I'll send you this recording and then we'll resume. Okay, I'll send you the time, but let's take a break. Right, thank you so much for joining us. It was awesome having this discussion. Taking a break now. We shall return, but I'm going to send you the time and we shall return pretty soon. Right. Taking a break refreshes the mind. It's good for the mind and it helps understanding. Thank you. Goodbye.